Hi, my dear students. Today we are going to discuss biomolecule. In biomolecules concept, different topics are there, different concepts are there. One is carbohydrate. In carbohydrates, which type of questions are asked? Means which is monosaccharide, which is disaccharide, which is polysaccharide. So what is glycoside linkage? What is nucleoside? What is nucleotide? And which is reducing sugars? And which of the following is non-reducing sugar? Which of the following is amino acid? Which is the non-essential amino acid? Next, which amino acid contains sulfur group? So, different types of questions are asked in amino acids. Next, different types of vitamins. What is the deficiency of B12? So, B12, what is the name of B12? What is the name of B1? So, which deficiency is caused by vitamin D? Vitamin D source. So, what is the source of vitamin D? What is the source of vitamin A? What are fat soluble vitamins? Which of the following is water soluble vitamin? This is very, very important biomolecules chapter. 1 mark guarantee if you listen carefully for this video. We'll start from carbohydrates. So what are carbohydrates? Optically active polyhydroxy aldehydes or ketones. First, it is optically active. That means it contains chiral carbon. Polyhydroxy, poly means many, hydroxy means OH group. Many OH groups of that is aldehyde or ketone. So example glucose. Glucose is aldehyde and it contains functional group OH also. So next ketones. Fructose is a ketone. It contains also hydroxy functional group. That means polyhydroxy aldehydes or ketones. They are called carbohydrates. So next carbohydrates are classified into monosaccharides, oligosaccharides, next polysaccharides. So what are monosaccharides? They cannot be further hydrolyzed to simple substances. Cannot be further hydrolyzed. It is the last final part. It cannot be further hydrolyzed to simple. So examples are glucose, fructose, galactose, erythrose, triose, ribose. These are all examples of monosaccharides. Next, oligosaccharides or oligosaccharides. Oligosaccharides means on hydrolysis gives 2 to 10 monosaccharides. 2 to 10 monosaccharides means example disaccharide. Disaccharide means on hydrolysis gives 2 monosaccharides, that is disaccharide. Trisaccharide means on hydrolysis gives 3 monosaccharides, that is called trisaccharide. So 3 monosaccharides. So disaccharides example sucrose, maltose, lactose. How to remember? So how to remember which of the following is disaccharide? So shortcut is సుమాల లేదా సుమా కనకాల యాంకర్ ఉంది కదా మనకి సుమా కనకాల అని గుర్తుపెట్టుకోండి. సుమా అంటే సుక్రోజు, ఎం మీన్స్ మా మీన్స్ మాల్టోజు, కనకాల లాస్ట్ లాక్టోజు, సుమాలా. సో నెక్స్ట్ ట్రైసాకరైడ్ రఫినోజు, అది మ్యాక్సిమం అడగకపోవచ్చు. నెక్స్ట్ polysaccharides on hydrolysis which gives more than 10 monosaccharide units, they are called polysaccharides. 2 to 10 means oligosaccharides, more than 10 means polysaccharides. So next example cellulose, starch, dextrin, glycogen, these are all examples of polysaccharides. సో పాలీసాకరైడ్స్కి మీరు షార్ట్ కట్ ఎలా గుర్తుపెట్టుకుంటారంటే పోలీస్ అంటే పాలీ, సెల్యులోజ్, టార్చర్, పోలీసులు టార్చర్ పెడతారు కాబట్టి టార్చర్ అంటే స్టార్చ్. సో ఈ రెండు బాగా గుర్తుపెట్టుకోండి, పాలీసాకరైడ్స్, సెల్యులోజ్, స్టార్చ్. సో నెక్స్ట్ రెడ్యూసింగ్ షుగర్స్, నాన్ రెడ్యూసింగ్ షుగర్స్. విచ్ ఆఫ్ ది ఫాలోయింగ్ ఈస్ రెడ్యూసింగ్ షుగర్? దట్ ఈస్ వన్ క్వశ్చన్. సో ద సాకరైడ్స్ విచ్ రెడ్యూస్ ఫెయిలింగ్స్ అండ్ టోలరెన్స్ రియేజెంట్. The saccharides which reduce Fehling's reagent and Tollens reagent, they are called reducing sugars. The saccharides which do not reduce Fehling's and Tollens reagent, they are called non-reducing sugars. So reducing sugars examples very, very easy. All monosaccharides are reducing sugars. So glucose, fructose, arabinose, galactose, all monosaccharides are reducing sugars. In disaccharides except sucrose, all disaccharides are reducing sugars. So except sucrose, non-reducing sugars, the saccharides which do not reduce Fehling's and Tollens reagent. Example sucrose. Next all polysaccharides. Sucrose, all polysaccharides. Polysaccharides means starch, cellulose, dextrin, glycogen. Okay, not this. Okay, next only the stereochemistry of all sugars is determined with respect to. సో అది డీనా ఎల్లా ఎలా ఐడెంటిఫై చేస్తామంటే బేస్డ్ ఆన్ డిఆర్ఎల్ గ్లిజరాల్డిహైడ్. it is the reference to identify the which one is D and which one is L. So DRL glyceraldehyde is the reference for to identify the stereochemistry of all sugars. So glucose, dextrose or aldohexose. Glucose is also called as dextrose. It is because dextrose sugar, D form, capital D. So next aldohexose. It contains aldehyde functional group, 6 carbons, aldehyde, O's means sugar. So aldohexose. Glucose is also called as aldohexose and it is also called as dextrose. So preparation, how to prepare glucose? Say the preparation, sucrose on hydrolysis in the presence of acid and enzyme invertase. So sucrose is converted into glucose and fructose. Glucose and fructose. Same formulas, C6H12O6, C6H12O6, but it is aldehyde functional group, it is a keto functional group. So after the formation of glucose, in the presence of gymase enzyme, very important, invertase gymase. So in the presence of gymase enzyme, it is forms ethyl alcohol and releases carbon dioxide. Very important. Sucrose anhydrolyzed in the presence of which enzyme? Invertase. So glucose is in the presence of gymase. So next, it has a pyranose structure. So it has a pyranose structure, but fructose pyranose structure. So these properties are given in the previous episode. Many properties are there, but these properties are important. Glucose, when reacts with hydrogen iodide on heating, which of the following is formed? So N-hexane is formed. Based on this, what we identify means all the carbons are in the linear arrangement. All the carbons are in straight chain arrangement. So glucose. So next, glucose reacts with bromine water. It forms. Which of the following is correct? Gluconic acid. Glucose reacts with nitric acid, HNO3 forms, saccharic acid. Glucose reacts with the excess of phenyl hydrogen. Phenyl hydrogen forms glucosazone formation. So next, glucose structure like this, straight chain structure. Aldehyde, CHOH functional groups are 4 and CH2OH. 4 secondary alcoholic groups, 1 primary alcoholic group, 1 aldehyde functional group. That is the alpha D plus glucose. If OH on second carbon atom left side is present, that is beta D plus glucose. So next, it is the cyclic structure. In the previous year we said in which carbon hemiacetal formation takes place. That is the one question. 5th carbon hemiacetal ring formation takes place. Okay, it is the Fischer structure. Okay, note this. Okay, glucose completed. Next, fructose. Fructose is also called as the livulose or ketohexose. Glucose is called as aldohexose, fructose is called as ketohexose. So that is dextrose, that is livulose. So formula same, C6H12O6. So preparation, how to prepare? Same. Sucrose and hydrolysis, acetic hydrolysis forms glucose and fructose. So structure of fructose is CH2OH, C double bond O. Remaining acid is glucose structure. So here this linkage 1, 2, 3, 4, 5. Hemiacetal linkage formation at 5th carbon. So it is furanose structure. Glucose has pyranose structure, fructose has a furanose structure. That's why fructose is called as fructofuranose. So next one, very important disaccharides, sucrose, maltose, lactose, suma kanakala, sucrose, maltose, lactose. Sucrose, cane sugar, it is inward sugar. Why it is called as inward sugar? Why it is called as inward sugar means first sucrose is dextro form. So after that on hydrolysis it converted to levo form. So that's why it is called as inward sugar. So next, what is the glycosidic linkage? Sucrose on hydrolysis forms alpha D glucose, beta D fructose. Alpha D, beta D, glucose, fructose. So glycosidic linkage, which one has glycosidic linkage? So glycosidic linkage is formed between C1, first carbon of alpha D glucose and second carbon of beta D fructose. Chonde sucrose okkate C1 and C2 linkage. Remaining anni kuda C1 and C4. Gurtupetteskoni, remember. Only sucrose, the glycosidic linkage between C1 and C2. Remaining all disaccharides, the glycosidic linkage is C1 and C4. But these compounds are different, these carbohydrates. So next, maltose. Maltose means malt sugar. Formula same, C12H22O11. So on hydrolysis forms, both are D-glucoses, alpha D-glucoses. Here alpha D-glucose, beta D-fructose. But maltose, both are alpha D-glucoses. So C1 of alpha D-glucose and C4 of alpha D-glucose is glycosidic linkage. So next, lactose. Lactose means it is present in milk, so that's why it's called as milk sugar. So milk sugar, ketone H22O11, same formula. Anhydrolysis forms beta D, both beta D galactose, beta D glucose. So C1 of beta D galactose, C4 of beta D glucose is glycosidic linkage. First galactose C1, C4 beta D glucose. Okay, note this, very very important. C1 C4 only sucrose, C1 C2, not this. Okay, dear students, monosaccharides and disaccharides completed. Next, polysaccharide, first one starch. So it is a polymer of alpha D glucose. So next one cellulose. It is a polymer of beta D glucose. Starch, alpha D glucose, cellulose, beta D glucose. So next, starch contains two compounds, amylose and amylopectin. Starch means alpha D glucose contains amylose and amylopectin. Amylose is water soluble, amylopectin is water insoluble. So amylose contains glycosidic linkage between C1 and C4, but amylopectin contains C1 and C4 in straight chain, but in branch starts from C1 and C6 branching. It is a linear chain arrangement. Next, cellulose. Next, it is a straight chain polymer of beta D glucose, glycosidic linkage C1 and C4. Remember, except sucrose, remaining all are C1 and C4 glycosidic linkage. Sucrose మాత్రమే C1 and C2. One is alpha D glucose, another one is beta D fructose. So next, objective. First one, in D glucose X and D fructose Y, which hydroxyl group participate in hemiacetal formation? Hydroxyl group participate in at which hemiacetal formation? Fifth carbon OH group, O is linked with first carbon. So C5 in both X and Y, both glucose and fructose at a C5, fifth carbon. So next, very important, 5th July 2022, 22nd April 2019, 2 times. So enzyme reaction. So invertase means sucrose is converted to glucose and fructose. Invertase enzyme is converted sucrose into glucose plus fructose. Next, pepsin. P వచ్చిందంటే PP, proteins, peptides. Pepsin, protein to peptide. P, peptide, చూడండి, protein to peptide. Next, diastase means starch. ST అని ఉంది కదా, starch to maltose. Diastase, starch to maltose. Next, trypsin means proteins is converted into amino acids. The enzyme trypsin is conversion of protein to amino acids. Okay, not this. Okay, see the next question. Reducing saccharides among the following are. Reducing saccharide means sugars. Reducing sugars among the following are sucrose, ribose, maltose, lactose, cellulose. So which one is correct? Sucrose. First, sucrose is a disaccharide. It is a non-reducing sugar. So sucrose is a disaccharide. It is a non-reducing sugar. Non-reducing. So next, ribose is a monosaccharide. Monosaccharides, all monosaccharides are reducing sugars. Maltose is a disaccharide, except sucrose, all disaccharides are reducing sugars. So ribose, maltose. Lactose, disaccharide. So disaccharide is reducing sugar. Cellulose is polysaccharide. Polysaccharides are non-reducing sugars. So answer is 2, 3, 4. 2, 3, 4. So option is D. So cellulose is polysaccharide. Cellulose, starch, both are polysaccharides, that is non-reducing sugars. So next question, see the next question, which is incorrect statement about maltose. So maltose is a disaccharide. So it is a reducing sugar. So correct. A is correct. Second one, it is composed of 2 alpha D glucose units. Correct one. So B is correct. It is composed of, it is wrong. Beta D glucose, beta D galactose. That is wrong. So it has 1,4 glycosidic linkage. So except sucrose, all are having 1,4 glycosidic linkage. So answer C. C is incorrect. C is incorrect. So next one, the correct statement about polysaccharides. So first, starch. Starch is a polymer. Starch, polysaccharide. It is a polymer of alpha D plus glucose. So it is correct. Starch is a polymer of alpha D plus glucose. Amylose of starch. Starch contains 2 components, amylose, amylopectin. So amylose of starch is not soluble in water. So but amylose is soluble in water. Amylopectin is insoluble in water. So it is wrong. So next, third one, amylose is a branched chain polymer of alpha D plus glucose. Alpha D plus glucose polymer of that is correct, but it is not a branched chain. It is a linear arrangement. It is a linear arrangement. So it is also wrong. Cellulose is a straight chain polymer of beta D plus glucose. Cellulose only straight chain polymer. So answer 1 and 4. So option A. The major products of the reaction is very important. It is including in organic chemistry. So glucose when it reacts with HI, glucose when reacts with HI and delta, it forms N-hexane. It is highly reducing agent, hydrogen iodide. All bonds are reduced to N-hexane. N-hexane means CH3, CH2, 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 6 carbons, CH2, CH3. So N-hexane is formed. After that, N-hexane, it reacts with molybdenum oxide, 773 kelvins, 10 to 20 atmospheres. So it is in organic. Molybdenum oxide or V2O5 or Cr2O3, whatever it is, MO2O3, Cr2O3, V2O5. At a higher temperature and 10 to 20 atmospheric pressure, it converts to aromatic form. First it is converted to cyclic form and aromatic chain is formed, aromatic ring is formed. So MO2O3 773 kelvins 10 to 20 atmospheric pressure. So then answer is benzene is formed. So option is B. So no check. Okay, see the next question, 7th one. Find the reagent that oxidizes glucose into saccharic acid. Bromine and water. Bromine water oxidizes glucose into gluconic acid. So it is forms gluconic acid. Gluconic acid. Hydrogen iodide delta. When hydrogen it reacts with hydrogen iodide is strong reducing agent. It forms glucose to N-hexane. N-hexane. So HNO3 to H2O. Nitric acid forms saccharic acid. Saccharic acid. HCN forms that is cyanohydride. So saccharic acid, it forms glucocyanohydrin. Cyanohydrin. So what is the formula of saccharic acid? Means COOH, single bond, CHOH 4 times COOH. So the top aldehyde functional group is converted to carboxylic acid. The lower primary alcohol functional group also converted to carboxylic acid. COOH, remaining secondary alcohols are 4 times. So the answer is saccharic acid forms HNO3 and H2O. Okay. Next question. Which of the very important 2 times adgaro. So next question. Which of the following carbohydrates has a glycosidic linkage? Which of the following carbohydrates has a glycosidic linkage? So fructofuranose, that means monosaccharide. Only disaccharides, polysaccharides have glycosidic linkage. Fructofuranose monosaccharide, mono, so it is not forms glycosidic linkage. Next glucopyranose means glucose. Glucose also does not forms, it is a monosaccharide. So it does not forms glycosidic linkage. Next maltose disaccharide. So disaccharide, so it forms glycosidic linkage between 1 and 4. 1 and 4 glycosidic linkage. Beta D fructose means again fructose. It is monosaccharide, it does not form. So answer is maltose. So next question, identify the non-reducing sugar. Maltose disaccharide, sucrose disaccharide, lactose disaccharide, glucose monosaccharide. All monosaccharides are reducing sugars. So it is not. So non-reducing sugar. All disaccharides except sucrose, that is non-reducing sugar. So only sucrose non-reducing sugars, remaining lactose and maltose are reducing sugars. Assertion, both glucose and fructose have the same D configuration. So glucose has D plus configuration. Glucose has D plus configuration, but fructose has LIVO configuration and D minus configuration. So D plus, D minus. D plus means dextro, D minus means LIVO. So glucose is dextrose, fructose is LIVOs. So both glucose and fructose have the same D configuration, correct. Both glucose and fructose are dextrorotatory is wrong, because glucose is plus form, that is dextro form, fructose is minus form, that is LIVO form. So answer A is correct, reason is wrong. So both glucose and fructose have the same D configuration, correct. So next, identify the product. C6H10O5 entames means it is starch. Starch on hydrolysis in the presence of acid at a temperature, high temperature and pressure forms. Starch on hydrolysis forms glucose. Starch on hydrolysis forms glucose. So answer is glucose.